In this video, I want to cover section 7.4, practical domain and range. Okay, so the definitions first. The practical domain of a function is a set of all possible values for the input variable that makes sense in a given situation. The practical range of a function is the set of all possible values for the output variable that makes sense in a given situation. What are they talking about? Makes sense in a given situation. Let me give you an example. Here in this spreadsheet, we have values that represent students' heights in inches. And so we have values that the minimum value here I see is 52, and the maximum value that I see was 78. Can't find it right now, but I know it's here somewhere. Anyway, so if for example, I want a graph, have a graph where my input value is the height and the output value is how many times it occurs in this data set. Let's say, 70 happens 4 times. So my point would be 70 for the input and 4 for the output. So here, I'm not going to have any inputs of 0 or 1, 2, 10, 20, 30, 37, so forth. Those values do not exist in this data set. And that means that I don't, my practical range, my practical domain for this data set is not gonna start with a 0. My practical domain may start with 50, right? I mentioned that the lowest value is 52, correct? So I can start my domain at 50 for practical reasons. I don't want to have this whole empty space between 0 and 50 where nothing happens. I want to zoom in to the piece of the number line where there is some action going on. So same applies for the practical range. If I have some output values that are starting, let's say, at 100, I don't want to start my, I want to, again, kind of like move to the portion of the line where the action happens. So let's take a look at an example cited here. It says the platform for the high drive is 35 feet above the water. A diver jumps from the platform and lands in the water after 1.5 seconds. The function h of s represents the height of the diver after s seconds. In this situation, what is the input variable? Well, remember, usually when we're dealing with time, something happens over time, then the time would be your input variable. So the time is the input variable and it is in seconds. So the units here are seconds. Okay, what the practical domain of this function is? Well, how do we figure out the practical domain? Think about what's the minimum value and what's the maximum value for this variable. It says that the diver jumps from the platform and lands in the water after 1.5 seconds. So when he jumps, the time is 0, right? That's the beginning of his jump, the time at the beginning of a process. Usually the time is 0. So our domain would be from practical domain is between 0 and 1.5 inclusive. All right, so that's going to be our practical domain for this function. The output variable in this situation, this is the function that represents the height. It takes in seconds for the input and outputs the height of the driver. So the output variable is the height. And what is, do we know the units? And the answer is right here, 35 feet above the water. So we're going to be measuring our height in feet. No reason to change it to anything else. We could if we wanted to, but we don't want to do that. Again, what is the practical range of this function? Well, what's the minimum and what's the maximum value for this function? So the diver starts 35 feet above the water. So that's the highest point. And when he dives, so again, this function, it measures the height above the water. So in 1.5 seconds, he lands in the water. So at this point, his height is 0, right? So our range would be from, he starts from 35 feet above the water and lands in the water where the height is 0. So the practical range would be from 0 to 35. We put the lowest value first, even though he starts with 35. So again, we're going to include both of those values because they are in the range. At some point, he will gain a height of 0, and at the beginning, he has a height of 35 feet. So this is it for the practical domain and range. Proceed to the next video.